All right, so let's take a look at section 2.6, the worksheet where we're looking at percentage problems. Percent of change describes how a quantity has changed. If the quantity goes up, the description is percent increase. If it goes down, it's a percent decrease. Concentration refers to what amount of a mixture is in a particular substance. So we're going to look at several things here. Computing discounts, we're going to compute markups, we're going to compute sales tax, and here's an example of a percentage of 30% of 60 is 18. In this case, is multiply. So if I were marking up 30%, if I had a 30% markup of something that was $60, that would be 0.30 times 60, which is $18 markup. Sales tax is a percent markup, actually. We calculate the sales tax by multiplying the tax rate by the purchase price. And that's a percent of increase. The new amount is the original amount plus the amount of increase. A percent of decrease is the new amount. I find the new amount by multiplying the original, subtracting from the original amount, that should be a subtraction, the amount of decrease. In mixture problems, I'm interested in concentration. So that's concentration is sometimes given as a percentage, and that's multiplied by the amount of mixture to tell me how much of a component I have in that mixture. Sometimes to find concentration we write it as a fraction. The amount of component is divided by the amount of mixture to get that fraction. So let's look at our problems. The first problems involve percentage, which percentage equation is the percent times the base, which always equals the amount. So in the first problem I have the percentage, which is 38%. I convert that to a decimal, and then I multiply that by the word that follows of. That's our base. So I'm going to use Mathematica as my calculator. So that's 58.9. So I'm going to answer this with a complete sentence. 58.9 is 38% of 155. So notice what I'd like for you to do when you're beginning these problems for your own benefit, and it's work that I want to see in your problem. I want you to start by writing what you have. In this case, you have that the percent, which is 0.38, and the base, which is 155, and it's A that you're trying to find. So I'd like for you to write that as an initial step in your problem, and I think you'll find that helpful. In number 2, I don't know the percent. That's my unknown. I know that the base, which follows the word of, is 55. The amount, which follows the word is 88. So when I go to write my equation, this time it's the P that I don't know. I know B and A, but I don't know P. So P times 55 is 88. If I divide both sides of that equation by 55, and I'm going to use my calculator to find that, and I want that in decimal form. This is how I tell the calculator I'm using. So that's 1.6. So 1.6 is my percentage. Now to convert that to a percentage form, I multiply by 100%. And you may wonder, how can you do that? Well, you have to remember that 100% is 1. I can always multiply by 1 without changing something's value. So 160% of 55 is 88. That's my final answer on number 2. So I'm going to circle the final answers in green. So number 3, 3,640 is 25.5% of what number? So I know the percentage, which is 2.5%. As a decimal, that's 0.025. I move the decimal 2 places to the left. In this case, my base is unknown. What follows the word of is unknown. A, in this particular way of writing, comes before the is, and that's 3,640. Is the same as equals. So in this problem, we've put what was on the left in problem 2 on the right of the equals. So 3,640 equals our percent times our base. So we need to divide both sides by the percent, 0.025, which is we have in decimal form, to find the result, which is 145,600. That's our base. Now notice 3,640 is 2.5% of 145,600. And we had an idea that this number would be really large because 3,640 is large. And it's only 2.5%, a very small percentage of the number I'm looking for. So that let me know that number had to be really big for 3,640 to be a small percentage of it. All right, let's look at number 4. A state university's board of directors approved a 6.5% tuition increase for next year. If the current annual let's go back to the original real quick. And this is actually a percent of increase. So let's just bring that so we'll have that right before us to refer to. So if the current annual tuition is $9,485, what will the tuition be next year? Round to the nearest whole dollar. Now what I want to point out here is that just in case anyone is having problems, whenever I remove a percent sign, I divide by 100. And that automatically will move the decimal 2 places to the left. So the new amount is found by adding 0.065 times the original amount. So that's the amount of increase. I find that by adding the amount of increase to the original amount. So let's go to my calculator. I'm going to move some of these things out of the way, some of my things that I've used this calculator for previously. So I'm multiplying 0.065 times 9,485. And I'm going to round that amount of increase to the nearest whole. So this is $617. And I'm adding that $617 to $9,485. And I get $10,102. So next year, tuition will be $10,102. And that's how I actually calculate that. Following an investigation into finance fraud, a daycare center's enrollment decreased by 30% to 56 students. What was the daycare center's enrollment before the investigation? So this is a percent of decrease. So what I'm going to do here is this time I know the new amount. I don't know the original amount. So I'm going to let my unknown equal the daycare center's enrollment before the investigation. Let me fix this. I'm going to start over here. So I want to make sure this is clear. So we're going to let X equal the daycare center's enrollment before the investigation. Now notice how I got that right from the question. So if you want to give a good description of your unknown, many times you can get that right from the question. So the new amount is 56, the original amount is X. The amount of decrease is my percent of decrease times my original amount. So I remember whenever I change a percent to a decimal, I remove the percent sign and replace it with division by 100. So 30% is 0.3. Now I have to understand when I go to combine X and a negative 0.3X, I have to understand there's an unwritten 1.0 in front of that X. So 56 is actually 0.70x. So when I do x minus 0.3x, I'm really doing x 1.0x minus 0.3x. And if you want, you don't need you don't need to write 0.70, you could just write 0.7. So I divide both sides by 0.7 to actually find my x. 56 divided by 0.7 is 80. So 80 equals x. So to give my final answer, I can just use part of what was in the original problem to give a good full sentence answer. The daycare center's enrollment before the investigation was 80. I don't want to just say 80. 80 what? 80 students. So that's how I would work a problem like that. And notice, to give good answers, I'm using the words from the original problem. All right, so on this next one, X is the overall price of the laptop. That's what I don't know. So this is really a problem involving computation of sales tax. So let's just bring that information here. So again, I got my description for my unknown right from the problem. I was told to find the overall price of the laptop. I let X equal the overall price of the laptop. So when we compute sales tax, the purchase price is added to the sales tax. So the purchase price is the $529.50. The tax rate is 7.5%. As a decimal, that's 0.075. I multiply that by the purchase price. And that product gets added to the purchase price. That product to the nearest cent is $39.71. I add those together and I get $569.21. That's the overall price of the laptop. And notice how to give a good sentence, I use words that were right in the original problem. The overall price of the laptop is $569.21. All right, my next problem is a mixture problem. So I'm going to go back to page 1 and I'm going to get the information about mixture problems, and I'm going to put that in front of us here. So we start with 8 cups of a 12% alcohol solution. We mix it with 2 cups of a 60% alcohol solution. We want to know what's the concentration of the new 10-cup mixture. All right, so concentration is multiplied by the amount of mixture to get the amount of a component in that was added to the mixture. So we're actually not going to use this fractional way of writing. So I'll get rid of that. So 12% is 0.12. Mixing, I need to understand, is the same as adding or addition. So when I mix things together, when I translate that to an equation, I'm adding these things together. So 0.12 times 8 is added to 0.6 times 2. And let's talk about what that actually is. So that's actually, first of all, what we don't know, taking words from the original problem, is the concentration of the new 10-cup mixture. So that's my X. And notice in every problem, concentration, in every part of the problem, concentration is multiplied times the amount. So this first product is the amount of alcohol in the 8 cups of the 12% alcohol solution. So I had 8 cups of that, and the concentration of alcohol in that was 12%. The amount of alcohol in the 2 cups of the 60% alcohol solution is 0.60 times 2. And the amount of alcohol in the new 10-cup mixture is whatever the percentage is, that's what I don't know, times the 10 cups. So that first product represents the amount of alcohol in that 12% alcohol solution. The second product represents the amount of alcohol in the 2 cups of 60% solution. And that third product on the right side of the equals is the amount of alcohol in the new 10-cup mixture. So the thing to notice, the pattern is concentration is changed to a decimal and multiplied by the amount in each of the 3 cases. So when I multiply 0.12 times 8, I get 0.96. 0.60 times 2 is 1.2. X times 10, it can be written as 10x. So I need to combine 0.96 and 1.2. I can think of 1.2 as 1.20, so both of these have two digits after the decimal, or on the right of the decimal. When I add this, I get 2.16, so that equals 10x. To solve for x, I'm actually going to divide both sides of this by 10. So 0.216 is my x. I can change this to a to a percentage by multiplying the decimal by 100%. And I get 21.6%. Remember, 100% is 1. That's why I can do that. So this is 21.6%. I'm going to get my nice full sentence answer by taking words that are right in the original problem. So the concentration of the new 10-cup mixture is 21.6%. And technically that